Good afternoon, everyone. I'm Dirk van Hyfte, the CTO and co-founder of BioStrand. At BioStrand, we are passionate about building the next generation technology that makes omics data analysis truly effective. So let's look at the hurdles in the current omics data processing. Well, we can say there is no common language. Quite a lot of information resides, and especially multi-omics data resides in different silos with domain-specific information. On the other hand, you have a bunch of disparate bioinformatic tools that you need to glue together to make sense out of all this data. And on the other hand, it's a massive amount of data generation. So it starts to outperform also even the computer power to analyze all this data. So there's really time to have something new so that we can really find all the knowledge and the results in all that data. So at BioStrand, we made a discovery. We found very specific patterns in multi-omics data. We have called them Hyfte patterns. And they are a kind of intermediate layer between DNA, RNA, and amino acids. It's a kind of new transversal language to glue all these different layers together. And on the other hand, they are very data-rich elements. They contain information about the structure, the function, the pharmacochemical properties, and so on. Based on these Hyfte patterns, and so that's the central place of our platform, we have built a platform to support drug discovery from sequence up to insight. And these Hyfte patterns are indeed the central place of our platform. And you can look at our platform from 4 different perspectives. First of all, you have the sequence level. There we have integrated the different omics layers, and it can be combined with your own proprietary data, but also public available data. The next dimension is that we have added also structure and chemical properties to this Hyfte patterns. A next step is the unstructured textual information. There we can tap in, for instance, scientific literature, but also PubMed and even electronic patient record systems. And that is combined with formal knowledge, so structural information that can reside in knowledge bases. So based on this platform, we have a unique way to analyze both at the sequence level, but also at the textual level, the information. So at the sequence level, we are using these Hyfte patterns to easily index and aggregate all this data. And at the NLP text analytic level, we have our own NLP pipeline. And that helps us to identify new knowledge, new insights in all this data. Let's have a look at how our workflow is and how we can go through our pipeline. So in a certain way, we can start off with whatever kind of sequence, because these Hyfte patterns, they are mined from the whole biosphere. So that means it contains information about humans, plants, virus, and so on. So you can use your own proprietary data also with their related metadata, but again, also public omics databases. We index this data set in a massive parallel way, and we add also the textual metadata. And that all resides in one single multidimensional model, where we have a fully data integration at the different levels, and not only at the sequence level, but also at the textual level. And once you have ordered all that data in a nice way, then it makes sense to start using AI and machine learning techniques. And then you can support, for instance, search, identify, cluster, and even predict certain features from your data sets. And that all on top enriched with evidence also that you can extract from the literature. And based on that, you can build your own hypothesis and test that with your data. So let's start with an example to explain how our workflow works. So let's start off with 1 million SARS-CoV sequences. And with that data, there is also metadata related, like based on the geography, certain epitopes, certain annotation, but also clinical outcome data. We index that massive set of data, cluster this, and it all resides in our one multi-dimensional information model. What's also important to understand that it's easy to add new incoming data, because this is an indexing principle. So that means new incoming data is also indexed by these Hyfte patterns, and it can be easily added already on your current index. So you don't need to rebuild the model from scratch. And that makes it very easy to also follow up the evolution, for instance, of the virus and also the different mutations in the populations. One task that we have looked at is to see if there are certain intersections at the Hyfte level with the microbiome and, for instance, the coronavirus. And that's what you see here. So indeed, there are Hyfte patterns that are both in the coronavirus, but also at the microbiome. And here we will further go into more detail that we see indeed elements that are in that intersection between the coronavirus and also Mycobacterium. So Mycobacterium is responsible for developing TBC of tuberculosis. So before we go in further detail, let's have a look at our NLP capabilities. So at BioStrand, we start off really from the data itself. So really a bottom-up approach. And what does it mean? That without predefined knowledge, so without knowing what's in a certain domain, we can identify all the meaningful word groups and the interrelationships between these meaningful word groups. And again, without predefined knowledge. So we have really control over the semantic word boundaries. And that's a key point, a very important part. And then in a next step, we combine this with dictionary matching, but also even deep learning models to do the annotation. And in that way, we have a massive index of concept relation, concept patterns, and see how things are related to each other. Just to give you a flavor of how this NLP pipeline works, so let's look at this sentence: 2 patients are suffering from congestive heart failure. So the first step that we are doing is what we have called in our smart indexing relation detection, is identify the relation between concepts. And mostly they are words, not always, it depends on the context of the concepts. But once you have detected these relational elements, then let's say everything that's left or right of that relation are concepts or meaningful word groups. So that means that in this specific case, we have it about 2 patients that are suffering from congestive heart failure. So we really grasp immediately these meaningful word groups. So let's go back to our example of the microbiome interaction with the coronavirus, where we have seen that, for instance, indeed, there is an interaction with Mycobacterium tuberculosis. And so now we are looking into the PubMed database, the PubMed abstracts that we have indexed, so around 30 million of these abstracts. And indeed, there we find relations between COVID-19 severity and the Mycobacterium tuberculosis exposure history. And of course, there are many of this type of relation, but here I just show you only one example. And the nice thing is that each edge between these concepts also points to a very specific text snippet or the specific sentence where this relation is mentioned. And based on that, we can indeed identify that there are relations between Mycobacterium tuberculosis and corona, not only we have found this relation at the text level, as you can see here, but also at the sequence level. So let's summarize this and see how we go through our pipeline. So as I said before, the first step is starting from our sequences. It could be DNA, RNA, or amino acids. We first do our Hyfte indexing. So it's in a massive way that we check against 660 million of these Hyfte patterns. And once we have identified the patterns, then we start looking at, for instance, sequence relations. And we can look, for instance, for epitope-paratope interactions, self versus non-self. For instance, if we are looking for antibodies, or like the example that I've demonstrated here, looking for interaction between microbiome and a certain virus, the coronavirus in this case. So once you have found this interrelations between the sequences, then we take all the annotations of the Hyfte patterns. We can rank them because there is a kind of ranking system between these patterns. And based on that, we can identify what we call top concepts. And top concepts are the main descriptions we are looking for and that we feed in our NLP or natural language processing pipeline. And from here on, we can extract very specific relations that are mentioned in the literature, and the whole pipeline, starting from sequence, we end up to knowledge and insight. So again, in one integrated model that can be queried in a massive parallel way. So I thank you very much for your attention, and hopefully we can meet also in a virtual way with our BioStrand team. So Audrey and Arnold, they are also joining the conference. And I also want to point out to the session on Thursday in the microbiome track. There I have a little bit more time to explain how we combine our NLP engine together with this dictionary matching and deep learning models, and what are the advantages of having that specific combination. So I really would like to thank you for your attention. And here you can see also our contact details, and hopefully we can see each other and meet each other during the conference. Thank you very much.